Hey guys, this is Mr.ScienceNY and I'm here with my first video, and I'm here to teach you an important lesson of chemistry in the book of Chem. So as you can see, it says by wisdom, and by wisdom I want to acknowledge all the important scientists who even give up their entire lives researching just one topic of chemistry. And really, without them, we wouldn't have all the modern day luxuries that we have, or majority of them, and that's including things such as iPhones or other cell phones or whatever you want to say. But they're very important, and I'll acknowledge that. So thank you. So today's lesson: properties of molecular substances, network solids, and metals. Right there is the father of chemistry. So if you want to know more about him, just go on Google, search up father of chemistry, and really research into him. It's very interesting. So guys, what are molecules? Well, molecules are discrete particles formed by covalently bonded nonmetal atoms. Furthermore, molecules are the smallest particle of an element or compound capable of independent motion. Examples of molecules include all diatomics and many acids, such as hydrochloric acid. So here are some diagrams or pictures of molecules. Properties of molecular substances. So low melting point and low boiling point. They are poor conductors of heat and electricity. They have different phases such as gases and liquids, and they can be soft solids or even brittle. So here's the phase chart. I think it's just really basic, but good to know. So what are network solids, guys? Well, network solids are covalently bonded atoms linked in a network, and there are no simple discrete particles in network solids. So as you can see here, these are two different allotropes of carbon. Even so, they're both carbon based. Because they have different structures or allotropes, really that gives them different properties. As you can see, diamond and graphite. Diamond is used in many things because it's very hard, and graphite is used on your pencil to write. So these are some allotropes of carbon, but once again, the most commonly two known are diamond and graphite. So examples of network solids. So one is graphite, the second is diamond, silicon carbide, that's an abrasive used in sandpaper, and other carbon allotropes in different forms. So once again, these are different structures of carbon which give them different properties, diamond and graphite. These are diamond drill bits, and they're used in construction because they're very hard. And this is sandpaper, so once again, silicon carbide, so it's an abrasive used in sandpaper. And that's graphite, that's your pencil lead, that's what you write with. Properties of network solids. So they have very high melting points. They're poor conductors of heat and electricity. They make good abrasives and are commonly used in cutting tools. So diamonds are a type of network solid, and it is very hard. On the Mohs hardness scale, diamond is a 10, so it's once again very hard. And diamonds, if you want to see them in common use today, now some companies such as Gorilla Glass are putting them in screens, so like your iPhone screen or your Android screen, whatever you have. And because it's so hard, they become really scratch resistant, so they're really working with it. And once again, they're used in tools that can cut because they're very abrasive. And yeah, so even so, that's an Android guy, and that's Android Nougat. We're going to use him as our mascot for network solids. So guys, what are metallic bonds? Simply, a metallic bond has positive ions immersed in a sea of mobile electrons. metallic bonds. So that's just another diagram. And you can see like delocalized electrons and metal ions. So you saw the fire, right? That means they have really high melting points, and they're really good conductors, because metals, guys, metals. They're very hard. They have a luster or shine. So if you look at something like gold right here, they're malleable. They can be malleabilities or drawn into sheets, or ductile even, drawn into wire. Most of these properties are the way they are because of mobile or delocalized electrons. The more delocalized electrons, the more enhanced the metallic properties. So right here. So guys, that's really the end, and thanks for